It's a circle. If you divide it into thirds, you divide 360 by 3, so this angle is 120. That's 1/3 of a circle, right? 120 degrees is 1/3 of a circle. Now, if you take another circle, same circle, well, it's 360 degrees anyway, and you cut that into 6 pieces, right? So we have 1, 2, 3, 4, 5, 6. So each of these measures 60. So there's 5 of them, which is 5, 6. So that'd be 300 degrees, 60. So 300 degrees, 5, 6 of a circle, of an arc of a circle, is how much more than this one, 120? Well, subtract, and you get 180, which is 2. We have a circle. We want to find the diameter. Okay, but we know that the area is 4 pi. So let's use the area formula. A equals pi r squared. I don't know the radius, but I know that A is 4 pi. So pi goes away. R squared, take the square root. Take the square root this side. And we're left with r equals plus or minus 2, but we just used the plus 2. So the radius is 2, which means the diameter is 4. Number 2 is 4. Number 3. We have a circle. The circumference equals q. The radius equals 4. What is the value of q? Well, so circumference equals 2 pi r. Circumference, they tell me, is equal to q, and r equals 4, so I'm going to replace that. So 2 times pi times 4. So q equals 8 pi. Do we have that? Yes. D. 4. Circle, the radius of circle q, we have a radius, it's 4 times the diameter of circle r. So this is circle q and this is circle r. There's diameter. You know what? Let's use some values. So let's pretend the diameter of circle r is 1. If the diameter of circle r is 1, this radius here is 4 times that value, which would be 4. What is the ratio of the diameter of circle q to the diameter of circle r? All right. So that's 4, and I extend this to the other side, means this is 4, which means the diameter of circle q is 8. So we want the ratio of diameter of q to the diameter of r. So it would be an 8 to 1 ratio, which gives us 5. Tire. There's a tire. It's 4 feet in diameter. How many feet does a tire move in one single revolution? So imagine you make a little X on your tire and you make it go 1 full rotation, right? So how much would it travel? Well, it would travel whatever this distance is, right? So, and that distance is called the circumference. So C equals pi d. C equals pi times the diameter, and C equals 4 pi, but they obviously multiply this. So if you multiply 4 times pi, you get approximately 12.5. So that would be number 5. Number 6. Okay, we have a bicycle. It's called penny farthing bicycle. That has a big front wheel and a smaller. Pretty sure you've seen these, at least on TV. The radius of the front wheel is 3 times larger than the radius of the runway. So this is, let's give this 1. So if this is 3 times larger, this would be 3. Here's your bicycle, right? For every 1 time the front wheel completes a revolution, so when the front wheel completes a revolution, let's use 1 revolution is the circumference, so C equals pi d. C equals pi, the diameter. Remember, if the radius is 3, the diameter is 6. For this one, C times pi d. So again, Radius is 1, the diameter will be 2. So every time the front wheel travels 1 revolution, it travels 6 pi, right? And in order for the back wheel to travel that same distance, right, it's going to have to do how many revolutions? 3 revolutions. 7. We have a square. We have a half of a circle here. We know this is 2, this is 2. And we want the area of the shaded region. Okay, so you can, the only information you need is that this is 2, right? From here of the circle and here of the circle. That's the diameter, which makes the radius 1. I can even erase everything because I don't need this anymore. So we want the area of that. So its area equals pi r squared, but we're going to divide that by 2 because it's a semicircle. So area equals pi, 2 to the second power. Sorry, not 2. The radius is 1. 1 to the second power over 2. So we get pi. 1 to the second power is 1 times pi is just pi. So pi over 2. So is there pi over 2 there? Yes, there is. So 8. 8. Circle A has a circumference of 8 pi. Okay. The radius of circle B. The radius of circle B. This is circle A, by the way. I'm going to call it circle B. The radius of circle B is twice the radius of circle A. Okay, what is the area of circle B? Okay, so first of all, let's use that information here. C equals 8 pi to find the radius. So C equals 2 pi r. We know C equals 8 pi, so let's substitute and then solve for r. That goes away, we divide both by 2, and r equals 4. So we know that the radius of circle A is 4. What did they say of circle B? So the radius of circle B is twice the radius of circle A, so that would make this 8. What is the area of circle B? Well, now that I know that, A equals pi 8 squared, A equals 64 pi, which makes it G, ladies and gentlemen. 9. Page over. We have a triangle or circle. I have something like this. Right? So this is S, this is Q, and this is R. Guys, so just pay attention. From the center to the edge of a circle is called a radius. So the center to call a radius, this is the radius. From the center to the edge of a circle, this is a radius. Right, so actually put it in blue. So that's the radius of the circle, and this is the radius of the circle. And what do we want? We want this angle over here. Now notice that this triangle, and I'll highlight it, right? It's an isosceles triangle. We know this guy's 90, right? So if that's 90, these two angles is going to be 45 and 45, right? Because if you subtract 90 from 180, you're left with 90 divided by 2, 45, 45. So that makes number 9 B. 10. Oh my God, what is that? So 10. I can. Oh, I do have a circle. Look, I can draw a circle. So here's a circle. That's A. That's 9. So the radius is 9. Radius is 9, and then we have this from here to here. Right. That's B. That's D, and this is E apparently. E, and this is C. There's a triangle. That's a triangle, and this is 7. Okay, so that's 9, right? So all these lines that start from the middle and go to the edge of the circle, that's 9, that's 9, this is 9, this is 9. Okay, so we know that. Segments EC and BD are diameters. EC and B, okay, diameters, okay, I knew that. AO represents the radius. Okay, which of the following statements is true? EC equals 9. No, EC would be EC equals 9 is the first one. That's not true because it should equal 18. A is not true, or E is not true. F it says ED equals 9. No, ED is not 9. That's also not true. FG 2 times AO, which would be 2 times 9, equals ED. Take that equal sign here. Equals ED plus BC. Absolutely not. And then H, 2 times AO, which is 9, equals EC. Well, this is 18. EC, which equals EC, which is also 18, so that's true, which is also BD, which is also 18. So H is the one you were looking for. 11. Oh my God. There is a line here. There's the ray center, and I'll try to draw this. Okay, and then we have a big O1. Something like that, right? Oh, look at that. Not bad. This is Q, and this is R. Circle Q has a radius of 5. So circle Q, this is 5, and this is 5, right? And circle R has a radius of 3, so this is 3, and this is 3, okay? The center of circle R is also the center of the large circle, okay? I'm okay with that, which means from here, so which means, okay, so which means, okay, the radius of the large circle, the big circle, which is this, I'm going to put it in red, right? From here to here, this whole thing is 13, which means this side is 13. Okay. Circle Q is tangent to circle R, right? And they're next to each other, as well as the largest circle. What is the diameter of the largest circle? And I will just answer this question, which is 26. And 11 is C. Did I do this right? Okay. 26. Yeah. No, D. 26. D. 12. So let me erase that, and let me erase that. So circle X has a radius 1/3 of a meter. Circle Y has a radius of 1 meter. Oh, so there's another circle. And the radius here is 1 meter. What is the ratio of the area of the circle X to the area of the circle Y? Well, okay, circle X is circle X and this is circle Y. We want the ratio of this circle to this circle. Well, let's find the area. A equals pi r squared. A equals pi times 1/3 squared. A equals pi over 9, so that's the area of that one. This one is A equals pi r squared. A equals pi 1 squared, or A equals just pi. So the ratio of X, so ratio of this to the ratio of this, let's write it, it's pi over 9 over pi. Can we simplify this? Yeah, well, let's go pi over 9 times the reciprocal, which is 1 over pi. We're left with 1/9. 1 to 9, which makes this letter E for question 12. 13. Well, 13, I'm going to use this. Okay. Order. Sent to the bottom line. so that's what we have. This is center, this is 4, I guess that's 4, T, Q, S, R for question 13. So that's 4. So the area of, what is the area of the shaded area? Oh, let me shade this. So we want the area of this. Now, the area of the square is 4 times area of the square. I'll put the square over here. 4 times 4, which gives me 16. But from that, we have to subtract the area of the circle. So I'm going to put a circle here. Area of the circle is A equals pi r squared. Do we know the radius of the circle? Yeah, we do, because I know that this over here is the diameter, right? Straight line going from one side of the circle going through the middle to the other side is 4, because that matches one of the sides of the square. So that's 4. That means this guy is 2. So A equals pi times 2 squared. A equals pi times 4. So the area is 4 pi. Now, to find the area of the shaded region, we do the area of the square, which was 16 minus the area of the circle. What kind of answer did they give us? Well, just like that. Letter C. 13. Next page. 14. 14. What is the circumference of a circle that has, okay, circumference, we want the circumference of a circle that has an area of 16 pi. Well, let's take that information. Area equals pi r squared. If we use that, we can substitute A with 16 pi. And cross out the pi's. Take the square root of both sides. And we're left with r equals plus or minus 4, or just 4 in the context that we want. So the radius of this circle is 4. The diameter is 8. So circumference equals C equals pi d. C equals pi times 8, or 8 pi. Do we have that? Oh, it's in sub 14. Okay, does it say how? So that's the answer. 8 pi, or if they want us to multiply, you can. 15. We have a square. Let me bring the square. Side length is 4. So this is 4, that's 4, that's 4, that's 4. A circle is centered. I guess that circle is in there. With a radius of 2, of course, right? So this is 2. That makes sense. To the nearest hundredth, what is the area of the section of the circle that is inside the square? What is the area of the section of the circle that is inside the square? Okay, oh, I didn't draw this correctly. So let me take this back. Oops, let me take this back. So what they meant was, here is a rectangle, here's a square. Let's call this A, B, C, D. I'm gonna have to move this to the left a little bit. And then they have a circle, radius to centered at point D. So here's a circle, and it's centered at point D. Okay. Let me just draw this. Maybe should move the circle just a little bit more, okay, just to make it more precise. Right. So, okay. Maybe make a square a little more. Okay. Well, hopefully it's a little better. So that's what we have, right? And we know the radius of this circle is 2. So this is 2. This is 2. They're asking us, what is the area of this? Okay, what is the area of the section of the circle that's inside the square? Well, now this is 1/4 of a circle. So A equals pi r squared, and we're going to divide that by 4 because we want 1/4. So A equals pi, the radius is 2 to the second power over 4, pi times 4 over 4, and area is just pi units squared, actually. Okay, which one was this? 15? Number 16. Alright, let me try to redraw this. Here's a circle. This is A. This is the center. This is measured, so the radius is 6. This is 6. This is B. And this is point O. Okay. Our arc AB, which is this guy here, right, is 4 pi units. What is the measure of angle AOB in degrees? Okay, so radius is 6. So if I can find a way. So let's find this is 4 pi units. So let's do this. Circumference equals 2 pi r. Circumference equals 2 times pi times the radius, which is 6. So circumference is 12 pi. So that means that if I traveled around this circle, right, if I traveled around this circle, it would be 12 pi. Now, let's see what I can do here. Now, if you notice something, well, if the full circumference of the circle is 12 pi, I need to notice that, I see, that this section over here, the 4 pi, right, is 1/3 of 12 pi, right? So that occupies 1/3 of 12 pi. That means that is 1/3 of the circle, right? 1/3. The arc represents 1/3 of the circle, which also would take 1/3 of 360, making it 120 degrees. Okay. 17. Circle O not shown has an area, so let's pick this circle. The area here has 81 pi square units. Circle P, well, there's another circle. This is circle O, so let's label it circle O. Circle P has a radius that is 2 units shorter than the other radius, okay? This is 2 units shorter than this. What is the diameter of circle P mean? Okay, so first of all, let's find the radius of circle O. So I don't know the radius. Well, I can use A equals pi r squared. Let's substitute. A is 81 pi equals pi r squared. Take that away. R squared equals 81. Square root of both, r equals plus or minus 9, or just 9. So this is 9. They're telling us that circle P has a radius that's 2 units shorter, so 9 minus 2, right? Which gives us this radius over here. So what do they want? What is the diameter of circle P units? Well, if the radius is 7, it means this other side is 7, so the diameter equals 14. I think I'm doing a little bit better than the plugin section. 18. 2 circles. That one and this one. This, yes. No. Oh my God, what just happened? Okay, sorry. That. Okay. I don't know what happened. I got 2 circles. I think got smaller. Right, we got 2 circles. The outer circle and the inner circle are concentric. Okay, so this one is inside the other one. The outer circle has a radius of 6. So the outer circle, this is 6. Everything got smaller. Even my pen got smaller. No. So the radius, the outer circle has a this. The area of the shaded region, which by the way, I can do this. Make this guy white so that we have properties. So let's make the circle white. Okay. So that's the shaded region. Okay. The area of the shaded region is 620 units. This is, the area is 20 pi. What is the area of the inner circle? Okay. Hang on. Okay, so I can find the area of the big circle. So what they're saying is they have a big circle, right? And the radius is 6. And that's the whole circle. So let's find the area. A equals pi r squared. A equals, what do you call? Pi times 6 squared. The area is 36 pi. So the area, so imagine somebody came, right? So the area of this whole thing here is 36 pi. Somebody came, punched a hole in the middle, and you're left with 20 pi. Okay? So that means that the area of this, the inner circle here, is 16 pi. So the area of this inside circle is 16 pi. Okay? What is the radius of the inner circle? Well, if I have the radius, so I need the radius, so I need this little chunk here. I know the area of the circle now, right? Because I subtracted. So we go a equals pi r squared. Replace this with 16 pi, pi r squared. These two are gone, and again r squared 16. Take the square root of both sides. The radius is plus or minus 4, or just 4. So this is the radius of the small circle. Okay. All right, that was actually, I feel a little bit better for providing you better explanations than the previous section. Okay, so that's it.